on an ICP product right here. It's not a carrier, I think it's just an ICP product, and we're running a third opinion call because I guess somebody else has been down here twice and struggled with trying to figure out what was wrong with it. But anyway, maybe they just couldn't figure it out. But anyhow, let's figure out what's going on with this thing. Homeowner says it's not keeping up when it gets cold. So it's on right now at the thermostat. We'll check the charge on it. Let's get this electrical panel opened up. See if we can find anything going on. So it says when it gets cold at night, it does fine during the day, normal temperatures, normal weather. Then it gets real cold, and at night it doesn't keep up. So with a heat pump, I tend to either think we got a heat strip problem or a heat pump problem. So it's running, so I know there's charge in it. I can hear the compressor. So let's see what's going on inside here. And yeah, it looks like somebody's already been putting parts in here for something. But we'll go over here and check the charge on this thing. See how it runs, see what the charge is on it. So we've got, pressures don't look all that bad. I mean, it's about 48 degrees out here today. It's not too bad. Oh, it's got one of those old, it's got one of these aftermarket compressors in it, Arco. Because quality doesn't matter. You'll find those Arco, these are rebuilt, remanufactured compressors, and that lets me know that a home warranty company has had their fingers in this thing. So you're not going to put one of these in this system unless you're working for a home warranty company and they give you a scroll compressor. That's what they're going to give you. So anyway, so I'm going to disconnect Y to shut this thing down for this noise. And I mean, I know my heat pump's working. Let's see if we get any heat strip amps in here. I'm not getting any amp draw on my heat strips, so let's see if we're actually getting a call for them. So I'm going to disconnect Y, shut this compressor off just to quiet things down just a little bit. Get that wire going for it. There we go. Alright, I just wanted to quiet this thing down some. A little bit loud. So we don't have an amp draw on our heat strips. So I guess what I want to do real quick is see if we're getting a call from the heat strips and then see if they're coming on like they're supposed to. So there's that. All I'm going to do is jump out 24 volts to my heat strips and see what happens. There. This unit definitely hasn't been maintained very much. Heat strips energized. Not getting a call. Let me try something. Maybe it's this other one, I think, because somebody has already bypassed something in here, looks like. Let's try this other wire. This is coming from there. This one's coming back over here from this board. Thermostat wire is going to this one. It's like somebody's actually disconnected the heat strips for some reason. Because this wire nut, the wire coming off of this one's the one going back up there to those heat relays. So let me energize that instead. Happening. Oh, okay. Now I see what our problem is. Let me get you some light so you can see back in there. Look at that. Toasted. Huh. So, International Comfort Products. There, I don't keep any of these relays. Now these may be DC relays. No, that wire's coming straight in here, so that should be a better look at it. Let's see what it says on the relay. Sometimes these units will have DC controlled heat relays in them. I might call them real quick and check on these heat strips and check on those relays, see if I can get one. I know I don't keep a lot of heater relays other than sequencers on the truck. I may be able to put one in here and make that work, but let me call over to the to our ICP guy real quick and see what he can come up with on these relays. So they do not make a replacement set of heat strips for this unit anymore, and those are actually, I got a little closer and zoomed in, those are DC controlled heat relays, which means they're controlled, the wires are coming back in and coming back off of this board. So it would be different if those were the relays that had the little box on top that the 24 volts went to and converted it to DC voltage to close the relay. This DC voltage is coming off this board, and that's how they're controlled. But at one time this had an X13 motor in it. Somebody has put a PSC motor in it, put this relay in it. I'm pulling those out and I'm going to replace them with a double stack heat sequencer, and then I'm going to do what they usually do, which is backfeed a jump wire to our normally closed on our blower relay to ensure that if that sequencer ever sticks closed or it's closed for whatever reason, we have heat strips, or we have airflow with our heat strips running. So that's the biggest thing about trying to do something like this. You want to make sure that in whatever case scenario, if you get a short for your auxiliary heat call or your heat relay or sequencer sticks closed, you want to be sure you've got airflow on those heat strips. Could probably find these relays somewhere, but they do not have them in stock available, and they do not have a replacement set of heat strips. Go figure. This unit's only 14 years old, but I'm going to replace that with some heat sequencers and get this thing running. Alright guys, so I'm going to pull this little relay out. I'm going to pull both of them out actually, and we're going to fix this with this little sequencer. Alright, so let's see, get these relays out of here. And where did my piece go to? Oh, there it is right there. Damn. Losing stuff. Ugh. Bit came off the end of my damn truck. So we will get these relays in or out of here. We'll get the sequencer in, and then I'll explain to you how to wire this thing up in this situation to make sure you got airflow when your heat strips are calling. Alright, that one is out. And this was the troublemaker. If I had one of those, I'd stick it in there It's just DC controlled. If you look right there on the thing, it actually says 28 volts DC, not AC. So that board sends DC voltage to close this relay. And there's another version of these that has a block that snaps on top, and the block will take AC voltage, change it to DC voltage, and then close the relay. And I used to have a couple of those. If I had a couple of those, I could just pull that block off and stick the relay in there and I'm good. But I'm gonna have to basically change this from DC to AC using heat sequencer. This board is what sends the DC voltage to those, and because we're not using that anymore, I'm gonna have to rewire the low voltage so that when the thermostat gives a 24 volt call, it goes and closes those sequencers. And then we're gonna do away with these DC wires coming off the board and not use them anymore. Okay, so got the sequencer in back there, and I don't know what the lighting's like, but it's in. And I have replaced my burnt leads off these wires, just clipped them back a couple inches, put new spade connectors on them. It's one of the old ones right there. It was melted in there pretty good. And now we're going to get this thing wired up, and I'll explain that to you. Alright guys, so I've got this thing wired up, and before we do this and show you how it's wired, why I wired it that way, and we turn it on, check it. The mistake that was made when whoever it was replaced this blower, this used to be an X13 blower. This is a DC controlled set of heat strips. The control board controls the airflow and the heat strips, DC voltage, and then obviously it was just an ECM X13 that was in there, 24 volts on that. Problem was, when they put this relay in here and replaced this thing with a PSC motor, what they overlooked was the fact that the original relays that were in there that I took out were DC controlled, and there was no way to backfeed off of those, or they didn't make an attempt. Probably could have used some jimmy wigglers to do it, but they didn't do anything to backfeed that when the sequencer closes, it energizes one bank of heat strips, but it also comes back on this wire to my normally closed switch to turn on the blower motor here if one of these sequencers was to get stuck closed or a relay was to get stuck closed. So the way they had it set up in here, after they did this and did this, there was no way to ensure you had airflow if your heat sequencer or heat relay ever stuck closed. So they would have had heat coils in there burning and going off. Yeah, you got temperature limits, things like that. But you really want to do something to ensure that if those heat strips are on intentionally for emergency heat or by accident and they're stuck, or you got a short on your W wire, you want to make sure there's something feeding back to run that blower so you've got airflow on those coils. Yeah, it's going to get hot in the house if they're stuck. But I'd rather be that than everything out here burning up. I'll burn up anyway. Just my 2 cents on that. You got to make sure, I like to make sure that when I'm doing a repair on heat strips, that if they're stuck closed and something's going on and they won't shut off, I have some resource that's going to come back and run this blower so I've got airflow. So anyway, and that's what I've done. I took the sequencers out, got rid of the DC voltage control. Basically, the board has been bypassed at this point. We're coming straight off the thermostat with W. We're energizing that sequencer. The brown wire down here is my common. When that sequencer closes, the first one to close is the stack at the top. And when it closes, it's going to do two things. It's going to energize this to the heat strips, and then it's going to come back on this wire and turn on my blower. Now, if the air conditioner or if the heat pump is running in regular heat mode, G is going to have airflow. I get that. The relay is going to be closed, and that's what's going to happen between these two terminals. It's going to close, energize the blower. You're going to have airflow. Heat strips are going to energize. You're still going to have airflow. And as long as this is energized and open, backfeeding something here, that will now become an open switch when G is energized here, so it doesn't matter. But I like to have something in here that if you have to run the emergency heat because you're waiting for a compressor and you energize these heat strips, when that sequencer closes, it's going to turn on the heat strips, but it's also going to come back here and it's going to run that blower so you've got airflow. Just the way I like to do things. But as you can see, that's the way I have it wired. Bank number 1 on the top, bank number 2 on the second set of contacts on this sequencer. And when the first one closes, airflow should start. Alright guys, so when I'm checking this after I do it, the first thing I always want to do, I want to put an amp clamp around one of my lines coming in for the heat strips. Because I want to make sure that they are not on unless there's a call for them to be on. And that's how I double check that. So we're going to put that there, set this for amps. Then I'm going to energize first G, because I want to make sure I haven't done anything, and I want to make sure that the only thing that runs when G comes on is the blower. And it does. And I did not have amp draw on my heat strips. So now we're going to start energizing the heat strips, and I want to make sure that the blower comes on as soon as the heat strips come on. I want to make sure that when the last bank shuts off, the blower is still running and this shuts off. And then I want to make sure that when it's just sitting idle, I don't have any heat strips energized or anything like that. It's just a way to double check your work. Make sure you're not leaving anything working backwards, so to speak. One more thing, guys, you got to remember, keep in mind, I have 2 circuits on this. I have a contactor compressor circuit, and then I have a separate auxiliary circuit. So for this to work, I had to put this blower motor on the same circuit as the heat strips are on. No different than having an air handler in an attic or a crawl space. Blower motor is on the heater circuit and not your compressor circuit. But that's what I had to do to make this situation work. So now we'll energize our blower. Our blower works. No heat strip amps, blower only. So now I want to energize our heat strips. Let that sequencer close and make sure the blower is going to come on with the heat strips. There's a time delay in that sequencer. Don't quite know how long. There we go. So as you can see, we have our 45.4 amps, so we got our heat strips and our blower motor running. Now I want to de-energize that. Make sure all that times out, and make sure the blower stays on until the last bank of heat strips shut off, and they did. Excuse me. And that's how you check that. So that's the way that you can figure out. Sometimes you got a burnt relay, you don't have one, you're in a spot, got to get something fixed. This is just one way, dealing with heat strips anyway, that you can get somebody up and running, and should have what you need on the truck. And now if it still had the X13 blower motor in it, that would be a whole nother situation. You'd have to maybe put a secondary relay in here with 24 volts to somehow tie in a separate circuit to run another blower speed when you get a call for the heat strips. I mean, I'm sure there's a way to figure that out, but anyway, in this situation, that is what worked. 2-stack sequencer and blower relay. Appreciate you guys watching, and have a good one.